Welcome to TEB 3043, Software Testing and Quality Assurance. We are in Module 5A on Data Flow Testing, the practical introduction. In this module, you will be learning to describe data flow graph for a program, develop data flow graph from code, and to perform data flow testing using the data flow graph. So what is data flow graph or DFG? Data flow graph represents the data dependency between a number of operations, mathematical operations, logical operations inside a program. DFG shows how the data inside the variable flows throughout the program. Why is this useful? Programmer can identify the algorithm steps to perform a computation. Usually, for a formula, a number of steps is required. Tester can combine data flow graph with control flow graph to get a more comprehensive understanding of the software application's behavior. By understanding the behavior of the program when it runs in real time, the programmer and the tester will be able to identify potential problems, potential vulnerabilities that are creeping inside the program. So if I were to ask you, what is the difference between control flow graph and data flow graph? Would you be able to tell me? The key point is control flow graph is investigating the flow of the control. The keyword here is the control. Control comprises decision as well as loop. Data flow graph, on the other hand, as you see here, is investigating the flow of data in contrast to control. The flow of data, how the data is being changed. So where is data stored? Inside a program. Inside a program, a data is stored inside the variables, right? Which is usually declared at the beginning of a program. Yeah, usually declared at the beginning, but not necessarily so. The data is impacted by the control. So it's often beneficial to look at both CFG and DFG. So a data flow graph looks typically like this. Question: what are examples of operators in the figure?
So is it the addition and the multiplication
Correct.
nodes?
Yes, plus, multiplication, yeah,
Yeah.
and greater than is a logical operator, plus is an arithmetic operator, multiplication is an arithmetic operator. Note that these operator signs are inside a circle, not a box. Box usually are used to represent data. So here, because operators are actually operations, a component of operations, a component of process, so they use a circle to represent it. Right? And then now data flow graph is mainly on the operators, but we can also have control. Yeah, but control is not the main feature of data flow graph because control is better represented inside control flow graph, CFG. However, in certain situations, we cannot avoid from showing some control. So yes, control can also be included inside DFG. And in this case, this symbol represents control. Yeah, if true or false. All right. And then, as I mentioned earlier, what is the use of the apostrophe? It is to represent that the value inside the variables have been updated. So a data flow graph typically look like this. Okay, the inputs here at the top and the outputs at the bottom, and the operations in between to modify the input values. So as you can see, we have a input variable becoming A apostrophe, B input variable becoming B apostrophe for the updated values, C input variable for the updated C apostrophe, which contain the updated values after the operations have been done on them. Okay, let's look at one example. Now, on the left-hand side here is part of the pseudocode. It means A plus B, the value of A plus the value of B assigned to X. The second one is the value of A multiplied the value of C assigned to Y. The value of X plus the value of D assigned to Z, Y, the value of Y minus D assigned to X, the value of X plus C assigned to X. So it is top down. That means the value that has been updated in the earlier row will be reused in the second row, right? Okay, for example, you see, X is assigned with Y minus D, right? So the value of Y, the value of Y is coming from the earlier row, which is, you see, the second row. The value of Y in the fourth row here is actually coming from the value of Y in the second row. You see? So it is being passed down. It's being passed down. Now, the value of X here, in the 1, 2, 3, 4, in the fifth row, the value of X here is coming from the value of X in the fourth row, not the first row. You see that? Because the value of X in the first row has been changed already in the fourth row. So we know that in programming, right? Now, how do we represent this as a data flow graph? Okay, how do you represent this as a data flow graph? This is how we do it. First, identify all the input variables. Okay, as you can see, we have A, we have B, right, as the input variable. So you just put A and B first. Okay, A, B. Okay, these are the input variables. Put A first, B. So what happened? A plus B. A plus B give you X, right? So this give you the value X, right? So we store the value inside the output variable. You see that? Okay, so we store inside X. Now, in the second, so we're done with the first row. Now the second row is A multiply C. Now A is already here, right? So we do not need to add another A, but there's no C, right? So we need to add C here, a new input variable. All right. So A is already there. So A multiply C. So we don't have multiply yet here. So we add multiply here. Okay. We add multiply here. So what multiplies? A multiplies C. A multiplies C, which gives us Y, right? So it gives us Y. So the second row is done. Then we systematically move on to the third row. Look, do we have a D input yet? Not yet. So we add another box and put D to label it. Yeah, to label the box. Inside the box are values. Yeah. And then what happens is that we are going to plus D to X. So we put a plus operation here. I'm going to plus it to X. This is where it becomes interesting. So where does X come from? Now, do we have X at the top here? A, B, C, D? We do not have, right? We do not have. So probably you will think of like adding another X box. You may think of doing this, right? But don't. This is wrong. Don't do like this. Yeah, you don't do like this. So if you don't do like this, what should you do? This is important. Don't do like this. What you should do is you look at the x. Where does the x come from? The x come from the first row x, right? This x come from the first row x. Correct or not? So the first row x is the addition of A to B. So remember, A plus B give you the x, right? So the result should be added to D. So this actually represents x. Yeah. So this represents x. And then the result is then stored inside Z. We are still at row 3 because I think you may have questions still. Why don't I just simply pull this x and put it here? Now, this is not advisable. Why? Because the green box x is the output. Yeah, is the output. So that's why we don't pull the x here and place it here. All right. Rather, we would reuse the x from the first row. So with that, we are done with the third row. Any questions so far? No question, huh? Okay. Now, let's move on to the fourth row. We do systematically. Look, we have D. All right, we have D. So is this D coming from any result? No. So this D is coming from the input D. Right? It's coming from the input D. And then what happened? Y minus D. So Y minus D. So we need a minus operator here. Minus D. Okay, this is done. Now, what is minusing D? It's Y, right? So where do we get the Y? Are we going to plug the Y from here? The answer is no. We don't plug because that one is the output, right? It's the output variable. So where then do we get the Y? If we don't get it from the output here, then where do we get the Y from? What you do is you look at the previous rows. Do you see this Y here? So we can use this Y. Okay, and this Y is a product of A multiply C. So let's find where is A multiply C. A multiply C, you see? Let me use another color. Let me use orange. You see? A multiply C gives you Y, right? So this Y now is being reused to minus the D, which gives you X. So with that, we are done with Y, and the value is also updated, right? The value is also updated. Look, these two are the same. It's fine. Yeah, we know that it's referring to the same X. Yeah, it's referring to the same X. If you want to draw the arrow straight to the other X, is also fine. Yeah, but because it looks messy, that's why we simply create another box and place it there. All right, and then we're done with the fourth row. Let's move on to the fifth row. Okay, the fifth row, we have C, which is already in the top input variable. We are doing plus operation. Okay, let's add a plus operation here, and it's plusing with X. And this X is coming from the earlier row, the earlier closest row, not this one. No, not this one. Not the first one. But the last closest row. Okay. So the last closest row. So the last closest row is Y minus D, right? y minus d. So it's y minus d, y minus d, which is this one, the output of this one. So we draw the arrow so that we can plus the y plus, we can plus the x with c, giving us an updated x. Okay. So we are done with all this already. We have managed to draw the data flow graph. Yeah. Let me clear this up. So what do we do? So why do we do this? What's the purpose of doing this? We have the data flow graph already, right? So what we do now is when we want to do the test, okay, we identify that we need to do test 1 on the plus operation. We need to do test 2 on the multiplication. And then we do test 3 on the another plus operation, test 4 another minus operation, and T5 on the other plus operation. So we need to test. We need to have 5 tests. Okay, we need to have these 5 tests. So that's the reason why we do data flow graph, to identify the required test cases to test the data flow. All right. Any question for now? Let's move on to example 2, shall we? Now, example 2 is a function. The name of the function is called func. And before the function, we have declared 3 variables. They are called A, B, C, integer variables. So we have 3 variables, A, B, C. And these are input variables. Yeah, they are input variables. Now, this ABC is accessible by the func function. So what happened in the first row of the func function? We increase the value by 1. We increase the value by 1. So let's look at B function. Let's look at variable B. We will increase it by 1. You see that? We add it with 1. So this value 1 is declared at the top so that it can be added to the function, to the variable B. And the result is stored inside B, right? Now, this B is an updated B. So we can put the apostrophe there. Okay. So we are done with this row number 3. And then let's go to row number 4. Okay. Row number 4 is using, do you see it as a control or as a data flow? Wait, you see there's a operator here, right? So operator is also greater than is also an operator. So therefore we add the operator greater than, and the value inside variable A is tested against 0 value. So we add 0 value here. We're testing against 0 value to see whether it's greater than or not. Okay. So the outcome is either true or false, right? The outcome of greater than is true or false. It's not another value, isn't it? The outcome is true or false. That's why you look at the arrow here. It's not going to any output variable, but it's going to this structure, which is either true or false. This is a Boolean structure. This is a Boolean structure. You see that? It's either true or false. Yeah, true or false. So we are done. We are done with this part. Now we go to the 5th row. We have A and B. So we have A and B, no problem. It's already added. And we have a new plus operator. A new plus operator. You see, the previously there's already a plus operator. We cannot use that one. Yeah, because that one is different. It's for a different operation. So what we need now is a new B. Is a new plus operator, which is this one. So we are adding A to B. We're adding A to B. Now, this is interesting. You may be thinking that, okay, I'm adding A to B. Okay, pay attention. You may be thinking that I'm adding A to B. So you may be tempted to take the B value here and draw an arrow there, right? Let me change the color. Cannot be seen, sorry. You may be tempted to take the B from the value from the B input variable, but why we are not supposed to do that? See why this one is wrong? Why this one is wrong? Why we're not talking from? Why are we not taking from B? From this input variable B? Can anybody make a guess why? The hint is that you must look at the recent closest B. The recent closest B. So where is the recent closest B? Which row? This B at the top here belongs to the first row B. You don't want to use it. You don't want to use it. Why? Because anybody can guess? You don't want this B. We don't want the B from the first row. Then, if we don't want the B from the first row, where can we get the value of B from? From which row?
The third row?
Correct, the third row. So the B must be coming from the third row. So in the data flow graph, right, the value of B plus plus from the third row, we may be thinking like, okay, just now we have the B, output, right? We have the B value. You see, the B output is coming from B plus 1, which is the result of B plus plus, isn't it? This is B plus plus. This plus operator is for B plus plus. Why not we take this value and plug it here? This is also wrong. Why not? It looks convenient, right? Why not? Why this is wrong? Why is this wrong? Why can't we just simply conveniently take the value of B here? You see, because this value of B apostrophe is actually B plus plus, right? Which nicely is equivalent to the third row, right? Why can't we just take this B apostrophe and just put an arrow pointed here? Shouldn't it work also? The answer is what? I earlier mentioned. Because all the boxes here are the outputs. We don't want to touch them. Okay, remember, don't touch them. So instead, if we cannot use the value from there, where can we get the value from? Note that just now, this operation T1 operation here, yeah, this plus operation here produces B apostrophe, right? Well, we just simply create another arrow connecting the output of this to this operation. So effectively, this is already B. This is the B plus plus B. Yeah, this is the B plus plus B. You see, it's equivalent of taking the value A plus it to the B++ output by doing so. You see that? You see? A plus the output of B++. So this plus, okay, is representing this part of the code. This A is coming from this. This B, right, is actually coming from this B++, which was earlier output of this. That's why we can take the arrow from B+1 and insert it here, because this whole thing in the circle here is actually this B++. Yeah, and we want to put the value inside here. So this B. So this whole thing, B+1, we want to put the value inside the plus operation, which will, yeah, the plus operation. Now this is inside the if block, right? So we place it in, we put the arrow pointing towards the if block. Yeah, because the outcome C, yeah, is depending on whether it's true or false. If it is true, we will plus. If it's false, we will multiply. That's why we have no choice but to insert both the output of A plus B and A multiplies B into the if else block, because the output depends whether it's true or false. And then the result will be stored inside C. Yeah, the result will be stored inside C. So we are done with this third. 1, 2, 3, 4, fifth row. Now, on the other hand, else, take A. So look at A. Is A coming from any variable? Yeah, it's coming from the top. So it's multiply, right? So A comes from the top here. Okay, let me clear up the ink first so that it's easier to see. Okay, so you see here, it's a multiply operation. This A, where is it coming from? Is there any closest A before it? The closest one is this input A, right? So input A is this. And then it multiplies with B. So this B, you cannot take this B. Cannot. You must find the closest B. So the closest B is this guy, right? In row number 3. You must take the closest one. And B++, as I have mentioned just now, is this guy. So we take the output of this and connect it to the multiply. This is how we get the B. Right? We cannot take the B from the bottom, because B from the bottom is actually output of B. It's all these are outputs, so we don't want to touch them. We don't want to touch outputs, right? So again, this operation A multiplies B is inside the if else block. So the output of C again is coming out to C, but the output, whether the C is getting the output from the plus operation or the multiply operation depends on the if else. That's why the output must come here first before going into C. All right. And finally, okay, we are done with the if else block already, right? And finally, the result of C the result of C, okay, is copied to A. So the result of C is copied to A. Yeah. Note that we don't draw the arrow like this, because these are already outputs. What we do is we are going to draw the arrow during the operation. So the operation is in the area in between the input variables and the output variables. So we can draw the arrow here. Yeah, we copy the value of C into A. Now this C cannot be from here. No, not this one. Because we are not taking from here. We are taking this C from either this C or either this C. You see, either the result of this C or the result of this C, giving the result C here. So we will take the value, we copy the value to A. So now this is the completed data flow graph. So what do we do with it? Again, we want to find out the required test cases. So how many test cases do we need here? 1 test case, 2 test case, 3 test cases, 4 test cases, and don't forget the copy operation. 5 test cases. Yeah, 5 test cases. Any questions so far for example 2? Example 2 is more interesting than example 1 because we involve the use of if-else, which impact the outcome of C. Because if the A greater than 0 operation is true, we will use plus operation, else we will use multiply operation. So the C depends on A greater than 0. That's why we have this unique block here. Contrast in example 1. Yeah, we don't have any if else. This is a simple one. And also note that we don't have X apostrophe or Y apostrophe. Why? Because earlier, the output variables are different from the input variables. We are not reusing the input variables for the output. So there's no need for X apostrophe, because at the top here, you see there's no input variable X. There's no input variable Y. Yeah. Whereas in the second example, you see the input variable A is also the output variable. So to differentiate them, we put apostrophe. One is for the output, the other one is for the input. Now, let's move to example 3, which is to draw DFG for a mathematical formula instead of from the code. Now, this is much more complicated. Yeah. Now, if you are given this formula and I ask you to write C++ or Java or Python code, what would you do? Do you think you're able to type this formula in 1 line? I don't think so. I don't think you can write this formula as 1 line of code. Yeah, because there is this plus minus. You can plus and also minus. Yeah, you can also plus and minus before you divide, right? Then you finally store in the output. So the output variable is what? The output variable is X, right? So this is the output variable X. How about the input variables? Are you able to tell from here? Of course, from the formula, right? B, A, C. So we have B, A, C. All right. And then other input variables Like this one, you see this B is actually similar. Actually, these two are similar. Huh? So in fact, we have three copies of the same input variables because the reason because is to make it more presentable, more understandable. If we just keep reusing the same B variable, then it becomes very messy. Yeah, the drawing becomes very messy. So this is allowed. And take note, a part of the variables, there's also a value that is being used in the equation, which is value 4. You see, value 4 and then value 2. All right. How about this A? Okay, this A again, you know, is just a duplicate of the first box. All right. And there's a zero. There's a zero value also, which is added during the process. Let's not take it yet. We'll see how it is used. Yeah. Perhaps I should let you try to scribble on your own on your paper of the DFG. Try not to look at this example yet. Yeah. Try to scribble. See whether you can come up with something similar to this. Let's take about 5 minutes to do that. Okay, time is up. Now you may look at the answer. You look at the answer. If you have done the exercise, you may realize that in this sample answer, there is a mistake. Is anybody aware of the mistake?
T9, sir.
Correct. Good. So what is wrong with T9?
Should be multiply.
Very good. Very good. I can't see your name. Your name, please? Amir. Thank you, Amir.
Yes.
You are absolutely correct. The mistake is here. As he mentioned just now, everybody, this is a mistake. It should be multiply. Why? Because you see, 2A is multiplication. Now, your drawing may not exactly look like this. Now, anyone wants to share their answer here? Okay, while waiting for Anna to paste or anybody of you pasting, I will try to sketch the answer here, yeah, and see whether your flow of thought is the same or not. So when I look at this formula, I know the output is X, yeah, the output is X, and the input variables are B, 4, A, C, and 2, all right? So I will start by establishing all the needed items here. So I look at the formula, negative B. So I will need a 0. Put a B here. I want to get the term negative B. So I need an operation. Need a minus operation. Okay, so I proceed while waiting for anybody to share their answer. So A and B, A minus B, it give you the minus B here. Okay, I'm done with this part. So I'm going to work on B square. So for B square, Okay, so prepare B square. Then I'm going to prepare 4AC. Four times. You see, if only I can just draw the lines 4A and C to multiply, right? But no, I must multiply 4 with A first, and then multiply the result with C. Or you may multiply A and C first, then multiply with 4. Yeah, it's entirely up to you. Both are correct. So I'm done with the negative B square minus 4AC. Okay, I'm left with 2A. I'm left with 2A. So I'm going to add 2A as the last input, as a last two input. Duplicate for 2. Okay, so anything else I left out? Okay, negative B, I got it covered here. B square, I covered here. 4AC, I got it covered here. And then 2A, I got it covered here. Now, I know B square minus 4AC, I need to put inside square root, right? So B square minus 4AC. So B square minus 4AC, I need to minus first. I need to take the result of B square minus with the result of 4AC. So when you do it, right, you will see the natural flow. You see like, oh, okay, no wonder it's drawn this way. You must draw it. You won't really get it why we are doing it this way. See, B square minus 4AC, right? So it's not, the arrow should be from here, not from here, but from here, because it's minus 4AC. All right. So B square minus 4AC. And then what else is the result after the minus is to square root. The result of the minus goes to square root. We have negative B plus minus the result of this, right? So this is the tricky part because we can do plus and minus, right? So let's do plus first. So what happens is that I'm going to take negative B plus with the result of the square root, right? Alternatively, look at this. I can also minus. This is how you do it. So the color doesn't matter. Color doesn't matter. I just put colors so that it'd be easier for you to see the two options. Yeah, either plus or minus. So you see here, you see parallel operation. You can do plus for both, or you can minus for both. You see that? And this is how we do it for this part. Okay, so the result of this will divide by 2A. So we need another operator. Yeah, we need another operator. Let's duplicate the symbol. Okay, so we're going to divide. All the result of minus will be divided over the result of 2A, right? I'll perform the divide operation of the plus result against 2A. And the other parallel operation is after I minus it. So the final answer, the output is X. Here, I don't find the necessity to have two output box similar X. Yeah. So I just draw one, and then the output become X. So this is my answer. Yeah. This is my answer. And as you can see, when you turn it into coding, right? You know that initially you need to generate these terms. Okay. You generate these terms. Number 1, number 2, number 3 and 4, 5, and then after that only 6, 7, 8, 9, 8, 9, 10, 11. Yeah. So you'll be able to identify the steps to the coding. Yeah. That will give you the correct answer. So anybody managed to share?
Yes,
Okay.
I put it on the second page.
On the second page. Okay, thank you, thank you. Okay, what she do is she prepare negative b, then she does b square, she does AC, she multiply AC first, then she multiplies with 4. Okay, so this is step 1, step 2, step 3. She multiplies the AC first, then only multiply with 4, and then she perform the terms for 2A. Okay, good. So all these terms are already ready for her. Then what she does is she work on this part. She work on the b square minus AC part. So she takes the result of this T2 and the result of T4. She minus them, which will give you T6, right? Then after that, she square root 8. So you see T6, T7. So just follow 1, 2, 3, 4, 5, 6, 7. So after she square root, this is where the parallel operations come in. The first one is plus, the second one is minus. So you want to put T8, T9 or T8, the other way is fine. Yeah. So T8, she plus, and then T9, she plus. Okay. And then the parallel action is that she will divide both of them, both the answers to give us X. All right. And then she will divide against 2A from the top here. Yeah, the result of 2A at the top here to get the result X. Okay, this is correct. Good. Let's look at the other one. Amir's answer. Okay. Amir also decides to do from left to right, apparently. You see, he starts with a negative B first. So 0 minus B. Okay, and then after that, he worked on the B square minus 4AC, B square, 4AC. He produced them nicely first, then minus them. Okay, and then he does the square root. Okay, then this is where the parallel operations come in, plus minus. So the result of 0 minus B and B square minus 4AC square root is fed into the same output. So the output for the input is fed as the inputs to the plus and minus operation in parallel with negative B. So it produces the result, which is then divided against 2A. So he decided to have two separate, okay, division, which is fine, which is correct, because these are two separate operations, because eventually the result, the value will be stored. Yeah, the value will be stored in the X, right? So you must do plus, then only divide. So you cannot like really share them. Okay, so then you store the result inside X. Okay, it also looks good. The flow looks sensible, reasonable. Okay, good. So let's go back to the slide. Thank you for the cooperation. So as you can see here, you can assign the label T1, T2, T3, yeah, as the sequence, as a sequence of the operation. These also are the things that you will test. You want to test whether the sequence is correct or not. In data flow graph, you want to test the sequence of the flow. That's why you need to identify how the operation is done with respect to the data, changes to the data. Then when you do the test, you also test in the same order. Yeah, you test in the same order. All right. So the algorithms, the test is done in the same order as the algorithm steps. Key points. A data flow graph can represent data flow from variables and the corresponding operations or controls on them. Okay? But the main thing is the data flow. Yeah. We want to see how the data change, the order, number 1, number 2, number 3. Number 2, data flow graph can indicate dependencies between operations. So we know which operation must be done first, which one is done later. Yeah? Which one must be done first, which one must be done first, which of them are couples, which of them are not related. And then number 3, DFG can be used to indicate algorithmic steps. Step number 1, step number 2. Yeah. And then data flow graph can be overlaid. That means you can use together with control flow graph. It's not an alternative, but it's done together to complement. It's done to complement CFG. So when you do the analysis, you can use both DFG and CFG. DFG is on how it impacts the data. CFG is how the control is flowing to see if there's any potential of error to occur. So that's about it for this module on data flow graph. With that, I would like to end today's lecture. So I will see you again. Thank you very much.